Ahead of time you can. All right. So again, when we think of perpendicular lines, we think two lines that intersect to form right angles. Correct. In the coordinate plane, there's something special about perpendicular lines, though. Who remembers what the relationship between the slopes would be? Jeremiah? Good. The slopes will be opposite reciprocals. The slopes will be opposite reciprocals. So one will be positive, one will be negative, and you'll be flipping out the fraction over. So for example, I can't see grid. Can you see grid lines on your paper for this or no? No. All right, so we'll just estimate. Let's suppose that this one was y equals 3x minus 1. The other line would have to be y equals negative 1/3 x, because you have to take the slope, which was 3 over 1, you have to take the reciprocal, which is to flip the fraction, and you have to change the sign. And then let's say that the y-intercept is maybe, like, since that was negative 1, let's make that positive 4 or something. Now I'm just kind of making those up. But the big thing to notice again is that the slopes, 3 and negative 1/3, are opposite reciprocals. So you're flipping the fraction and the sign. Now what this says is it says if you multiply the slopes together, you will get 1. I don't really like to think of it that way, but that does happen. So if I were to multiply 3 times negative 1/3, excuse me, I'll get negative 1. I will get negative 3 over 3, which will simplify to be negative 1. But I like to memorize, and like you to memorize, this part. Now their y-intercept can actually be the same or it can be different. So the y-intercept is kind of irrelevant. Now parallel lines, we know, are two coplanar lines that never intersect. But when we're looking at the equations of these, they are actually going to have the same exact slope. But they have to have different y-intercepts. If they were to have the same slope and the same y-intercept, it would be the same line. There wouldn't be two lines. It would just be a line on top of itself. So for example here, we might have y equals 2x plus 4 and y equals 2x minus 1. That's an example of parallel lines. You'll notice that their slopes are exactly the same. Their y-intercepts are different values. So sometimes you'll just be asked, are they parallel or perpendicular, looking at the equations. So you just want to observe the slopes and the y-intercepts. Sometimes you'll be asked to write an equation of a line, parallel or perpendicular. So example 1, are the two lines parallel or not? You do not just want to use your eye and say, yes, they look like they'll never intersect. Okay, so if these are parallel, then they must have the same slope. And they must have different y-intercepts. Okay, so first of all, we can see that their y-intercepts are obviously different. This one goes down somewhere off the grid. Now we want to check the slopes. Okay, and you might want to use the points that they gave you, since we're not sure that that actually goes through. So the slope of this line would be up 1, 2, 3, 4, 5, 6, 7, 8, 9. And over 1, 2, 3. So the slope of the first line is 3. Now the second line, again, if they give you the points like this, I would use those to do rise over run. You also could do, if you prefer, you could use your formula and actually plug those values in if you're someone who likes that better. But graphically, it's a little bit easier. So I'm going to start with the leftmost point. I'm going to say how much do I rise up, how much do I run over. So this will be up 1, 2, 3, 4, 5, 6, 7, and running over 2, which is 3.5. So no, these are not parallel. The explanation would be that they have different slopes, or the slopes are not the same. So even though it looks like they might never intersect, they will eventually at some point intersect. It just might be obviously off our grid. Now, example B doesn't give us a graph. It gives us a set of ordered pairs. So for this one, when we check the slopes, we would want to use our formula for slope, y2 minus y1 over x2 minus x1. Labeling these x1, y1, x2, y2. Remember, point 1 has 1s, point 2 has 2s. So for line A, I would do y2, which is 1, minus y1, which is 2, over 3, minus a negative 4. So in the top I'll get negative 1, in the denominator I'll get 3 plus 4, which is 7. So I'm going to get negative 1, 7 for the slope of line A. For line B, you're going to have to label the points the same way, x1, y1, x2, y2. Substitute into our formula. And see if we get negative 1, 7. So we'll have negative 2 minus 0 over 8 minus a negative 4. So minus a negative becomes plus. So I'll get negative 2 over 12, which if I were to reduce that would get me negative 1/6. Slopes are not the same, not parallel. Different slopes. Okay, example 2 says determine which of the lines, it's multiple choice, is going to be parallel to the given line. Now the big mistake students make is that they're like, oh, the slope is negative 12 because that's what's with the x. But right now this is in standard, well, it's actually not even in standard form because the x and the y are backwards. Okay, so the first thing that you want to do is you want to get this into slope-intercept form. So we're going to solve this for y first using inverse operations. So I want to solve for y, so here's my y. So the first thing would be to undo addition or subtraction. So I see minus 12x, the inverse would be to add 12x to both sides. So we will have 4y equals, now you cannot make this 32x because one has an x, one is just a number. So those are not like terms. All you can do is write them next to each other. So 12x plus 20. So 4y equals 12x plus 20. Now again, we're asked to solve this for y. So we have to use inverse operations. I see multiplication, so I'm going to divide. You do want to divide any number you see by 4. Okay, so this is the same equation as that, it's just rearranged. Now we can observe that the slope is 3, the y-intercept is 5. And we're asked which line would be parallel. Well, we know for a line to be parallel, they have to have the same slope, but they must have different y-intercepts. So basically just looking at the equations, which one also has a slope of 3? Equation A. Now make sure the y-intercepts are different, -1 and +5, they are. So my answer choice would be A. Now let's suppose it wasn't that straightforward. Maybe this was -3. Okay, we would eliminate that. You would actually need to solve each of these, well I guess just this one for y, to see the slope. So for this one you would have to check it normally, and you would get y equals -3x plus 5, and you would see that that has a different slope. But in order to identify slope, you do have to get it in slope-intercept form. You cannot leave it in standard form. All right, now these are the ones that a lot of you screwed up in Algebra 2. So if you want to pay attention for just one of these, just as a refresh, you might want to, but it's up to you, you know yourself. Write the equation of each line. It's going through this point, and it has to be parallel to this line. So again, if a line is parallel, we know that it has to have the same slope, but it has to have a different y-intercept. And I should have told you what form to put this in. So let's just say slope-intercept form. Now, even though I want the answer in slope-intercept form, that's not necessarily the form you're going to start with. So first of all, we look at the equation. Y equals negative 4x plus 3. The slope we can see is negative 4. So if we want this line to be parallel, we know that the slope, the m value of our new line, has to be exactly the same. So jot down m equals negative 4. We're going to keep the slope exactly the same because it's parallel. Now, even though they want this in slope-intercept form, the information you have right now is only this. We have a point, and we have the slope. So we are going to start with point-slope form. In Algebra 1, I would say about 80% of the time, you're going to use point-slope form even when they don't ask you for it. So we're going to plug in, again, this is your point. So this is your x1, y1. Remember, the y itself and the x, they stay there as variables. So we'll get y minus a negative 2, which will become y plus 2, minus a negative, equals m, which we identified as negative 4, times x minus x1, which is 1. And then I do want this in slope-intercept form, so at that point I have to distribute and solve for y. So I want to distribute this first. We'll get negative 4x, and then this is where a bunch of you screw up. This is a negative 4 times a negative 1, which is a positive 4. When you distribute, you have to keep the sign in front of the number. And then lastly, we will subtract 2 on both sides. 4 minus 2 is a positive 2. And then always double check, are these lines parallel? Yes, they have the same slope, they have different y-intercepts. See if you guys can try the next one. Write the equation of a line that goes through this point that's parallel to the line y equals negative. This is really y equals a negative 1x plus 4. On the back, we're going to switch gears into perpendicular. So determine whether the lines are perpendicular or not. So remember, perpendicular lines intersect and they form right angles. Now you cannot just use your eye, you have to check the slopes. The slopes need to be opposite and reciprocals. So I say flip the fraction, flip the sign. Flip the fraction, flip the sign. You flip both. So if it's a positive 1/2, you flip it to make it 2/1, and you would make it a negative. So it would be negative 2/2. So first question, are these perpendicular or not? So we need to check the slopes and see if they're opposite reciprocals. So since this is a graph, I would use rise over run to check. Again, using this formula, you want to start with the leftmost point. So I'm going to start with L2. Oh well, whatever. And I'm going to see how much I rise up or rise down, sink down. So this would be to get to this point, I have, and some students like to make a triangle out of it, if that helps you. I'm actually drawing segments. But I'm going down 1, 2, 3, 4, 5, 6. And I'm running over 1, 2, 3, 4, 5, 6, 7, 8. So negative 6 over 8, which would reduce to be negative 3/4. Now the other line, my L1, I'm going to start at this point and try to get up to that point. Again, start with the leftmost point, we're rising up, 1, 2, 3, 4. And I'm running over 1, 2, 3. Are these opposite reciprocals? Do they flip the fraction and flip the sign? Yes. If I flip this, it's 4/3 and I change it to a negative, so these are perpendicular. And you'll remember the perpendicular symbol looks like this if you ever see me write it. That way I don't have to write out the word perpendicular. Explain, you can say the slopes are opposite reciprocals. Now for example B, we have points given to us. So just like we did on the front, we're going to have to use our formula. y2 minus y1 over x2 minus x1. And so we'll plug in for line A. We would have -2 minus 5 over 3 minus 0, which will get me -7/3. For line B, and for those of you that might look at me at the board and say, how is she doing this formula so fast? It takes me forever. Again, I'm a visual person, so like when I look at this, I see take the second number minus the second number, like the y value minus the y value. So I see 5 minus 1. Then I'm taking the x value minus the x value. And you have to go in the same order, like from the second back to the first. So this will be 5 minus a -4. So if that helps anyone with the formula, what we should get, 5 minus 1 is 4, and then 5 minus a -4 become a plus. 5 plus 4 is 9. So we have 4 9s. So these are clearly not opposite reciprocals. They don't have the same numbers. The only thing they do have going for them is one's positive, one's negative. So these are not perpendicular, okay, because the slopes are not opposite reciprocals. Okay, and then the last two problems are similar to the ones on the front, but this time they want us to write the equation of each line. Again, let's do in slope-intercept form. On the test it will specify. But this time it'll say going through a point, but it has to be perpendicular to this line. So the slope is no longer going to be the same. The slope is going to be an opposite reciprocal. So you want to look at the original slope of the original line, which is 2. When we identify what m is for our new line, it has to be the opposite and the reciprocal. So this is not a fraction. Let's make it into one, 2 over 1. So we flip the fraction to be 1/2, and we flip the sign and make it negative. So one has to be positive, one has to be negative, and they are just flipped. Now, we're going to use this slope, which is really our perpendicular slope, along with this point, x1, y1, and we're going to plug into point slope. So even though this is the format I want to get to, it's not, we don't have enough information because I don't know what b is. So we'll start with y minus y1 equals m times x minus x1, and we'll sub in our values. Y minus a -3 equals -1/2 times x minus 4. Minus a negative will become a positive. And actually at the same point, just to save space, I'm going to distribute this. Now those of you that struggle with fractions, -1/2 times x, that's easy. -1/2 x. When you go to multiply -1/2 times a -4, you may want to put it over a 1. To multiply fractions, that's easy. Multiply the top numbers, numerators, multiply the bottom numbers. You do not need a common denominator. So first of all, I'm going to have a -1 times a -4, which is a positive 4. And then I have 2 times 1, which is 2. So 4/2, which let's go ahead and simplify that, right? That's just 2. Now, not always will it simplify. Sometimes you have to then add fractions. Last step, solve for y, so we use inverse operations to subtract 3. 2 minus 3 is a -1. And make sure that that looks like a negative, either in the front or in the top. Okay, I'll start you off with example B, and I'll let you guys finish it up. Again, we're going through this point, which is our x1, y1. We want it to be perpendicular to this line. So we're going to take the opposite reciprocal of this, which would become 3 over 1, and it has to become negative. So our new slope is a -3, or a -3 over 1. And then you're going to do the same process, plugging in the point and the slope that we found. See if you can simplify that. They write it in standard form. So you just want to read the directions. If they want this in standard form instead, all you have to do is move the x over using inverse operations. So you ask yourself, what is the sign? What's the inverse? And then you always put the x first, so that's why you'll see me write it over here. So if I were to put this in standard form, on your test, I'll tell you, there's one question that says write an equation parallel, like on the front. One will say write the equation of a line that is perpendicular. One of them will tell you to do it in slope-intercept form. One will tell you to do it in standard form. And that's testing that you know how to do both forms. So just make sure you read the directions carefully. On the test, there's also a series of questions like this, where you will just tell me parallel, perpendicular, or neither. So to identify what type they are, you just have to observe the slopes and y-intercepts. So again, we know parallel lines have the same slope, but they have different y-intercepts. Perpendicular lines will have slopes that are opposite reciprocals. And neither would be if they don't categorize as parallel or perpendicular. Now you can see A and B are really simple. They're already in slope-intercept form. Y equals mx plus b, y equals mx plus b. So you just have to look at the slopes. Okay, you can see they're not the same, so they're not parallel. Are they opposite reciprocals? 3 and negative 1/3? Are those opposite reciprocals? Yeah. So these would be perpendicular. You can either put the symbol or you can write the word. Example B is also easy because this is already in slope-intercept form. So we observe the slopes, same slope, 4/5, 4/5. So right now they appear to be parallel. Let's check, are the y-intercepts different? Yes, they are. So these lines would be parallel. If you want, the symbol for that is just 2 bars going up and down, or you can write out the word parallel. Now the last one, most students would just assume it's neither because there's one of each, but that's not necessarily the case. This one is the harder one because this is not in slope-intercept form. So what you have to do, you cannot just say, oh, the slope is 2 and the slope is negative 4. That's wrong. You actually have to solve each of these for y. So you're going to make 2 separate questions up here. Solve for y. So first of all, I'm going to move the 2x over. So I'm going to subtract 2x to get negative 4y equals negative 2x plus 8. And then lastly, to solve for y, I have to undo multiplication with division. Make sure you divide each number by negative 4. And also remind yourself that 2 negatives do cancel out or become a positive. So this would become a positive 2/4, which is 1/2. And then positive 8 divided by negative 4 is a minus 2. Okay, so I can now see my slope is 1/2 and my y-intercept is negative 2. So you can see the slope was not 2. Do the same thing with the other one. Now here's my y. So I want to leave that alone, so I have to move the x term over. So I will add 4x to both sides to get negative 2y equals 4x plus 8. And then divide each term by negative 2. And I will get y equals negative 2x. 8 divided by negative 2 is a negative 4. Now I can observe the slopes. They're clearly not the same, so they're not parallel. But are those opposite reciprocals? Yes. These are opposite reciprocals, making these lines perpendicular. Okay. All right, your homework is the 3-7 worksheet, and then you guys can start studying for the chapter